Hello, kids, and welcome to the very first episode of Salutary Spade Science. Well, for those of you who are subscribed to the old Salutary Spade Science, you know that there were previously Salutary Spade Science videos, but there are no longer any Salutary Spade Science videos, with the exception of this one. And we're going to be completely redoing that whole science thing, except on the Salutary Spade Gaming channel, so it's easier to access. So excuse me. All right, and we're going to continue be doing physics, and yes, and when this is going to be a lot more structured, and this will be easily watched. These videos will be easily watched back to back in a playlist at the end. And so first, we're going to talk about classical mechanics. Classical mechanics. Classical mechanics. I don't know how well you can see that. Hold on. Hold on a sec. I'm going to use one of my chemistry books to hold this up, and I hope to eventually get to do some biology and chemistry and stuff like that. Hopefully you can see that a little better. So, yes, classical mechanics is basically everyday physics. Exactly what you'd think of when you think of physics. That's pretty much all there is to it. And in this video, I just want to get into the difference between a vector field and a scalar field. So let's write those out. Vectors, and scalars. See? There's vectors and scalars. So what's the difference between the two? Well, how about let's start by giving you an example of a scalar. A scalar, so it's basically like saying what's the difference between speed and velocity, right? And in physics, we very rarely use speed. We very rarely use speed because speed is a scalar field, and what that means is that something that is in a scalar field gives you a magnitude, and only a magnitude, and velocity is basically speed, but it has a direction too. So like for example, a scalar, a speed would be like 25 miles per hour, and then a velocity would be 30 miles per hour north. Right, it gives you a direction too that's more specific, okay? And some other examples of a scalar and a vector, like for example, wind would be, if you wanted to model the wind speeds or wind velocities in different places as like a map, then that would be a vector. Wind would be a vector, but temperature would be a scalar, because the temperature isn't, well, I mean, you can think of it as moving somewhere, but it's not actually moving anywhere. You can't draw, there isn't a quantized unit of temperature that you can direct, and that, single unit of temperature is not being directed in a specific direction. So basically, if we wanted to, yeah, that's basically the difference between a scalar and a vector, and that's lesson 1 of our physics. This will be called defining motion. Defining motion. I hope you enjoyed this episode. My name is Yuichi Greywright from Salutary Spade Gaming and Science. I'm just so used to saying gaming because I haven't done the science videos in a while. So my name is Yuichi Greywright from Salutary Spade. How about that? And I am signing off now.